3 boys and 4 girls can be arranged in a row so that all the 3 boys are together. Now let us consider these 3 boys as 1 unit. 1 unit plus 4 is 5 units. In these 8 places, we are going to fill how many teachers? 4 teachers. So 4 teachers are going to fill in these 8 gaps. Let us consider 2 girls as 1 unit and the remaining 4 girls and 6 boys. 6 plus 4, 10 plus 1 unit is equal to 11 units. This can be arranged in 11 factorial ways. Hello dear students, welcome to this session of basic mathematics class. I am Mr. Niranjan, Faculty Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. So, in this session I am going to discuss the problems based on permutations. Now, in the previous class we have discussed it regarding the introduction, fundamental principle of counting, that is addition and multiplicative theorem, then representation, factorial rotation, and the problems based on factorial, and the definition for permutation with a small example with repetition and without repetition, and formula for permutations and the problems based on that. So those things which we have studied in the previous class. Now in this session I am going to discuss regarding various types of permutations. So the problems based on various type of permutations. So type 1, things always occurs together. How to find the permutation if the things always occurs together? That is type 1. Things always occurs together. To find the permutation, I'll take few problems. Next, type 2, things occurring together more than one type. First one is things always occurs together. The second time, things occurring together more than one time. Similarly, the third type is one type do not occur. One type do not occur together. And the fourth one is no two of a certain thing do not occur together. No two things. No two of a certain things do not occur together. And now, based on this, let us take few problems. Now, move on to the first type. In the first type, type 1, when a certain number of things always occurs together. Always occurs together. Now, let us take an example. In how many ways can 7 people, how many people? 7 people be seated in a row for a photograph if 2 particular people always want to be together. So that means certain number of people always together, occur together. Based on this, this is an example. In how many ways can 7 people be seated in a row? So 7 people can be seated in a row for a photograph if 2 particular people always want to be together. Now 7 peoples, we have to arrange 7 peoples. Here, that is at least 2, that is photograph if 2 particular people always want to be together. Now how to find out the permutation? Now here what is given? 2 people. So 2 particular people always together. Now let us consider these 2 particular peoples as 1 unit. Now let us consider the 2 peoples, that is 2 particular people as 1 unit. This is 1 unit. The remaining 5. So the remaining 5% plus this 1 unit. So totally this is equal to 6 units, right? 6 units. So that means here the permutation is remaining 5% plus 1 unit is equal to 6 units. This can be arranged in 6 factorial. And these 2 together can be arranged in 2 factorial ways. So therefore, the total required permutation is nothing but the multiplication of these 2. That's it. Okay. So therefore, the total permutation is equal to 6 factorial into 2 factorial. What is 6 factorial? So that is nothing but 6 into 5 into 4 into 3 into 2 into 1 into 2. This is 720 into 2. That is nothing but 1440 ways. So in 1440 ways we can arrange the given 7 person for a photograph. Right, that's it. Hope you followed. Now move on to the next type problem. In how many ways can 3 boys and 4 girls can be arranged in a row so that all the 3 boys are together? Here how many boys? The number of boys. There are 3 boys And how many girls are there? So there are 4 girls. Totally there are 7. Total 3 plus 4, that's equal to 7. So in how many ways can 3 boys and 4 girls, 3 boys and 4 girls can be arranged in a row so that the 3 boys are always together? Okay, this is the given condition. Now very simple. Now let us consider these 3 boys as one unit. Consider 3 boys as one unit. So therefore then 4 plus 1 is 5 units. Therefore the required permutation is equal to, that is 5 factorial into 3 factorial. That's it. So the required permutation is 5 factorial into 3 factorial. What is this equal to? The 5 factorial, 5 into 4 into 3 into 2 into 1 into 3 into 2 into 1. Simplify this. What is this equal to? 5 factorial means 120. 120 into 6. So that's equal to 720 ways. That's it. This is the required permutation. That's it. Okay. 720 ways. Listen. See here. In how many ways can 3 boys and 4 girls, 3 boys and 4 girls can be arranged in a row so that all the 3 boys are together? Now let us consider these 3 boys as one unit. 1 unit plus 4 is 5 units. Therefore the required arrangement is 5 factorial into 3 factorial. That's equal to 120 into 6 is equal to 720 ways. Now move on to the next type, second type problem. When certain number of things occurring together more than one time. This is type 2. In type 2, when certain number of things occurring together more than one type. So let me take an example. In how many ways can 7 maths books, how many maths books are there? Maths 7 books, and 8 statistics books, 8 statistics books, and 4 accountancy books are 4. Accountancy books can be arranged in that way. Can the books be arranged if books of the same subject are always together? The books of the same subject are always together. So here how many maths books are there? 7. Stats books 8. Accountancy books 4. Right. Now very simple problem. Here consider all the mathematics books as one unit. Consider all 7 maths as one unit, stats books as one unit, and all accountancy books as one unit. So totally there are 3 units. Right. Now all these books, what is the condition given? Can be arranged in that way that can books be arranged if books of same subject are always together. So if you multiply all this, you will get the required permutation. So therefore the required permutation is equal to 7 factorial into 8 factorial into 4 factorial into 3 factorial. That's it. So this is the required arrangement. Listen to me. Consider all maths books as one unit and all stats books as one unit and all accountancy books as one unit. So totally there are 3 units. So 3 units, that is nothing but 3 factorial, and all the books always together. Same subjects, maths, accountancy and stats must be all together, always together, means 7 factorial into 8 factorial into 4 factorial into 3 factorial. What is the simplified answer for this? So put it in order. So this can be written as, therefore the required permutation is 3 factorial into 4 factorial into 7 factorial into 8 factorial. That's it. Now move on to the next type, type third one. So type 3, when certain things of one type do not occur together. That is, when certain things of one type do not occur together. Now let us take an example for this. In how many ways 9 boys and 6 girls be arranged in a row if no 2 girls are together? So here one type do not occur together. In the previous will occur together. Here it do not occur together. That means out of 7, 9 boys, 6 girls. In how many ways 9 boys and 6 girls be arranged in a row so that no 2 girls are together? Okay. Now how many boys are there? There are 9 boys. And how many girls are there? 6 girls. Right. So let us arrange the boys first. So these boys can be arranged in 9 factorial way. Suppose if it is arranged like this: B1, B2, B3, B4, B5, B6, B7, B8 and B9. Okay, 9 boys can be arranged in 9 factorial ways. What is the condition given? 6 girls be arranged in a row if no 2 girls are together. Okay. Now, let us consider here, in these gaps, we are going to arrange the girls, right? So, we are going to arrange the remaining 6 girls in these gaps. Condition, what is the condition? No 2 girls are together, right? So, how many places are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places. So, in these 10 places, we are going to arrange 6 girls, right? So, this can be arranged in 10p6, right? See here, very simple concept. There are 9 boys. 9 boys can be arranged in 9 factorial ways. Let us consider the boys B1, B2, etc. up to 9. So here the girls, the remaining 6 girls can be arranged here in the gap. So that means all these 10 places can be filled by the 6 girls. The condition is no girls are together. So therefore the total ways, is equal to 6 factorial into 10p6. That's it. This is the required answer. Hope you followed. Let us move on to the type 4. When no 2 of a certain things do not occur together. No 2 of a certain things do not occur together. For this, let us take an example. In how many ways 7 students and 4 teachers be seated in a row such that no 2 teachers are together? So how many teachers? 7 students and 4 teachers. So in how many ways? 7 students and 4 teachers can be seated in a row such that no 2 teachers are together. No teachers. How many? 2 teachers are not together. This is also a simple example. How many students are there? There are 7 students. So 7 students can be arranged in S1, S2, that is 7 factorial ways: S1, S2, S3, S4, S5, S6 and S7. So here in these gaps, so how many places are there? 1, 2, 3, 4, 5, 6, 7, 8 places. So in these 8 places, we are going to fill how many teachers? 4 teachers. So 4 teachers are going to fill in these 7, in these 8 gaps. So all these 4 teachers can be filled in 8 gaps in 8p4 ways. So that means all the 4 teachers can be filled in this gap by 8 places by 8p4. So therefore the required arrangement is equal to 7 factorial into 8p4. That's it. 7 factorial into 8p4. Okay. Now let us move on to the next problem. Let me read. 5 men and 4 women. How many men are there? 5 men and 4 women. So 5 men and 4 women are to be seated in a row so that women occupy the even places. So women can occupy the even places. How many such arrangements can be possible? So here, out of 5 men and 4 women, so they can be arranged in a row so that women can take only the even places, right? Now, how many men are there? There are 5 men. So the men can be arranged like this: M1, M2, M3, M4, M5. So here, how many places are there? So in this 1, 2, 3, 4, 5, 6, in 6 places, we are going to arrange 4 women's. Right. Now, here the arrangement is nothing but how many such arrangement can be possible occupying only the even places. So how many even? So there are 4 even places. Right. 4 even places. So that means therefore men's can be arranged in 5 factorial ways, and whereas women's can be arranged in 4 factorial ways. So men's can be arranged in 5 factorial ways and women's can be arranged in 4 factorial ways. So therefore the total arrangement, is equal to 4 factorial into 5 factorial. That's it. So this is the required answer. So if you simplify, you will get the answer. Okay. What is this equal to? 4 factorial, 4 into 3 into 2 into 1 into 5 into 4 into 3 into 2 into 1. Simplify, you will get the answer. 4 is a 12, 12 2 is a 24. 24 into 5, 120. 120 into 24. That's it. Okay. That's equal to 2880. 2880 ways. That's it. Now, move on to the next problem. This is an important problem. In how many ways can 6 boys and 6 girls can be arranged in a row so that all girls are together, all the boys are together, no 2 girls are together, boys and girls arranged alternatively, 2 particular girls are always together. All types of all cases will repeat here. So, in how many 6 boys and 6 girls? So, how many boys are there? There are 6 boys. And how many girls? There are 6 girls, right? Now, one by one, let us take all girls are together. Now, let us move on to the first one. So, here the total permutation is 6 plus 6, 12 factorial, right? So, first one, the total number of permutations is equal to 12 factorial. 12 factorial is the total permutation. Now, first one, A. All the girls are together. So, how many girls are there? 6 girls. Now, consider these 6 girls as one unit. If we consider all the 6 girls as one unit, then, so all the 6 girls are considered as one unit. So, then how many boys are there? 6 boys. So, therefore, 6 boys plus 1 unit, that's equal to 7 factorial, right? The remaining 6 boys plus 1 unit is equal to 7 factorial. That means the 6 girls can be arranged in 6 factorial ways. 6 girls can be arranged in 6 factorial ways. So, therefore, the required permutation all girls together is equal to 6 factorial into 7 factorial. So, the first answer is 6 factorial into 7 factorial. That's it. Now, just consider all the 6 girls as one unit. Then 6 plus 1 is equal to 7 members. Then all the 6 girls are arranged in 6 factorial ways. Therefore, the required permutation is 6 factorial into 7 factorial is the required answer. Now, move on to the second one. What is the second one? All boys are together. Same condition. All girls are together, whereas all boys are together. Now, move on to the second condition. All boys are together. Same. Consider all boys as one unit. Consider all the boys as one unit. So, all boys as one unit. 6 boys as one unit. Then, therefore, the total number of members, 7 members are there. So, all the boys can be arranged in 6 factorial ways. So, therefore, the required permutation is nothing but same, 6 factorial into 7 factorial. Okay. Now, move on to the third one. No 2 girls together. No 2 girls are together. Third one is no 2 girls are together. Now, what is the condition? No 2 girls are together means no 2 girls are together. That means girls can be placed in between the boys. That's it. So, how many boys? 6 boys. So, no 2 girls are together means, so the girls are placed in between the boys. So, therefore, this can be done in, see here. So, how many boys are there? Let us consider B1, B2, B3, B4, B5 and B6. So, here these gaps can be filled by the girls, right? So, in between these, the girls can be placed. So, girls can be placed in between this. So, how many places are there? 1, 2, 3, 4, 5, 6, 7. 7 places can be filled by 6 girls, right? Okay. So, the 7 places can be filled by 6 girls in 7P6 ways, right? Now, and the 6 boys can be arranged in 6 boys can be arranged in 6 factorial ways. So, therefore, the required permutation is equal to 6 factorial into 7P6 ways. That's all. This is the required answer. So the 6 girls can be placed in 7 places by 7p6 ways, and the 6 boys can be arranged in 6 factorial ways. So therefore, the required permutation is 6 factorial into 7p6. Now move on to the next one. What is the next one? Boys and girls arranged differently, alternatively. Sorry. Boys and girls arranged alternatively. 6 boys and 6 girls can be arranged alternatively. Right. So very simple here. 6 boys and 6 girls can be arranged alternatively means 6 boys and 6 girls can be arranged alternatively in 6 factorial into 6 factorial ways. That's it. Very simple. 6 boys and 6 girls can be arranged alternatively means 6 factorial into 6 factorial ways. That's it. Now, the last, what is the last? 2 particular girls are always together. How many? 2. 2 particular girls. So, 2 particular girls are always together. Okay. Now, let us consider these 2 girls as one unit. And what are the remaining? Then remaining 4 girls plus 6 boys. Right. Then 1, this is nothing but 10 units plus 1, that's equal to 11 units. So this can be arranged in 11 factorial ways. See here, very simple. Let us consider 2 girls as one unit and the remaining 4 girls and 6 boys. 6 plus 4, 10 plus 1 unit is equal to 11 units. This can be arranged in 11 factorial ways, right? So also the 2 girls can be arranged in 2 factorial ways. Now therefore, what is the required permutation? So therefore, the required permutation is equal to 2 factorial into 11 factorial. That's it. 2 factorial into 11 factorial. So this is how we are going to solve the problem. See, very simple here. The fourth condition, 6 boys and 6 girls can be arranged in 6 factorial into 6 factorial ways. Whereas the fifth one, 2 particular girls are always together. Consider the 2 particular girls as one unit. Then what is remaining? 4 girls plus 6 boys plus 1 unit, totally 7 units. So 11 ways. So they can be arranged in 11 ways. And the 2 girls can also be arranged in 2 factorial ways. So therefore, the required permutation is equal to 2 factorial into 11 factorial ways. That's it. This is how we are going to solve the problems based on case 1, case 2, case 3 and case 4. Hope you followed. So, that's all regarding today's session. Let us meet with a different concept in the next session. Thank you. Thank you very much.